Okay, hi class. Today we're going to continue lesson from yesterday. So yesterday we were learning how we can use and find the greatest common factor and least common multiple. And then we did, today we're going to use another strategy. We're going to use and find the greatest common factor and least common multiple by using a Venn diagram and prime factorization. So greatest common factor, stand for, and least common multiple with prime factorization factoring, I can use that, prime factoring, and a Venn diagram. Okay, so to greatest common factor, remember from yesterday, we have a factors of a number that multiply together. So for example, factors of 8 are 1, 2, 4, and 8, because I can do 1 times 2, 2 times 4, 8, and 1 times 8, 8. But prime factorization are prime numbers. So who knows what are prime numbers? Let's do them a little bit. Mention some prime factors. Anybody know what prime factors and composite numbers? You remember prime numbers and composite numbers. What would be a prime factors or prime numbers? Anybody understand it?
It's a number that can only be multiplied by 1.
Kiss your brain. Bravo, Marcus. Yes, I'm so smart. So that's exactly, so 1 and 1 itself. So what that means is if I start thinking 1 is not prime neither. 1 is just not prime or not composite. But you just remember that. But you can use 2 because 1 times 2 is 2. There is no other way you can do that. But if I try 3, is it 3 prime or composite? Who knows? Is there any other way to make 3? No, guys, it's only 1 times 3 is 3, or 1 times 2 is 2, and that's it. What about 4? Is it prime or composite? If you have 2 ways to multiply 2 factors to find a 4, do you have 2 ways?
Yes.
Yeah, you have 2 ways.
Tell me what are 2 ways?
2 times 2 and 1 times 4.
Bravo. So that's not a prime number. How about 5? Is there 2 ways to multiply 2 factors to get the 5?
No. No.
It's only what?
It's only 1 times 5.
1 times 5 is 5. So that's right. I'm gonna just do a few more, like 2, 3, 5. 6 is not, because 2 times 3 and 1 times 6. So 7 is. 8 is not, if you think about 2 times 4 and 1 times 8. 9 is it 9 composite or prime? What do you think?
Composite, because you can multiply 3 times 3 and 1 times 9.
Excellent. So that does not mean that like if it's odd number, it has to be the prime number. That's not true. So it's 9 is not. And 10 is also not. But 11 it definitely is, or maybe 13, and they go forever, guys. So we can put comma, and then you can put that that symbol. So we need to know that if I do prime factorization, I needed to decompose any number. I can decompose it in a different prime factors. So I kept on a decomposing until I'm done and I don't have any more numbers. So for example, yeah, we're gonna use a simple numbers like we did if we have 8, and then if we have 12. Okay, so we're gonna use factoring tree. So we can decompose 8 because 8 is a composite, correct? So I need to know that which prime factors will create 8. So what do I do, guys, to make 8? 2 times, oh, I already says. What is it? Anilada, can you tell me?
Sorry, one more time. My brother's
Okay.
class is playing music.
Find me 2 factors that when you multiply them get 8.
2 times 4 and
okay.
1 times 8.
Oh, just a second now. I'm doing the tree. I'm gonna find how many primes who could make 8. So you told me 2 times 4, and then I already have a 1 prime. I can circle that. But then I have a 4 here, and that is also can be further decomposed because 4, as you can see, it's not a prime number. I want to make each number to decompose in only prime numbers, and that's possible. So how I can make 4 with 2 factors of multiplication? Come on, guys.
2 times 2.
2 times 2, bravo, Alex. 2 times 2. And look, I did decompose 8 into its primes. So if I have 8, every number can be decomposed in the prime numbers. That's just their way that you can decompose. So 1 is 2 and 2 and 2. And you can check. Alexander, what is 2 times 2 times 2?
2 times 2.
What is 2 times 2?
2 times 2 is 4.
And times 2?
Is 8.
There you go. So 8 is equal of the primes. That is 2 times 2 times 2, which is 2 on a power of what? Who knows that? 2 on a power of what? 3, bravo. Or exponent 3, because we multiply 3 times, and that is a 2 on a power of 3, or 2 with exponent 3. And now I need to do 12. I kind of gonna use messed up here. I'm gonna put 12 right here. So now you know. So somebody needs to help me how I can decompose 12 into 2 factors.
6 times
Come
2.
on. Okay, Alex, stay with me. 2 times 6, did you say?
Yeah.
Okay, or it could be 3 times 4. It's okay. Even if you do 3 times 4, it's still fine. You can keep. So do you see any primes in between 2 and 6 already? Alexander, stay with me. Which one is prime, 2 or 6?
2.
2. So I already have one prime that makes 12. But what I'm going to do now with the 6? 6 is not a prime. As you can see, it's not. It could be multiplied with 2 factors in more than one way. Okay, what do I do, Alex?
Multiply 3 and 2.
Bravo. So 3 and 2. And that is it 3 prime? Is it 2 prime?
The 2 is prime, yes.
Is it 3 prime?
No.
Oh, look at this.
I mean, yeah.
Find me another way to make a 3.
1 times 3.
That's it. 1 times 3 is 3. You cannot do, like if you do 6, you can say 3 times 2 is 6, but you also can say 1 times 6 is 6. Those are 2 ways to make a 6. That's why 6 is composite. While you have a 3, it's only 1 times 3 is 3, or 2, 1 times 2 is 2, or 5, 1 times 5 is 5, and that's it. So right now you have 12 is equal to the primes 2, 2, and 3. So I like to use like 2 and 2 and 3. So now I can do the exponential form as well. This. What do I do, Alex? 2 on the power of what?
2 on the power of 2.
Bravo. And then 3 is just power of 1. So usually they don't put 1, but you can think about 3 if there is no power that it's power of 1. Okay, so now you have those primes numbers, and then they said how they can connect with the greatest common factor and least common multiple. They can do that by using a Venn diagram. And Venn diagram is just 2 circles that they interact each other. So if I have this circle to represent my 8, and in this circle that will represent my 12. So I need to know that if I have interaction here of 2 circles, that means the inside of that goes the number that is common for both. So you're gonna just write once. So as you can see, I have here in 8, I have 2, but then also in 12, I have a 2 as a prime. So I have in both 2. So I'm going to use that as written here. The 2, these 2 belong to both of them. So place them inside of the intersection, and it's going to be in both. So now I use that, and I'm just like crossing off that because I needed to see if they have more numbers in common. Do they have more same numbers in common? Did they have a more number? Yes. What is another again? It could be the same number, guys. It's okay. So what is the same in this 2? Does this one has a 2 also?
Yes.
Yes. So that is also 2. So we can say, oh, they have another common number. And I'm going to cross them off, and I'm going to put here 2. So, but then I look a lot numbers that are left. I only have a 2 here. And so that is not, I don't have over here another 2. Or here I have 3, but I don't have a 3 in other side. So these are going to stay in their separate circles. So I will have 2 belongs in here, and then 3 belongs to there. And now it's just a simple, when you place them in, you can check, look, 8, 2 times 2 times 2 is 8. And then 3 times 2 is 6, 6 times 2 is 12. So this circle means 12, and this circle means 8. But you can see that if you multiply numbers that are in intersection, you know what is their greatest common factor is. And in this case is 2 times 2 is equal to 4. So right now, the greatest common factor for number 8 and 12 is 4. Okay, and if I needed to find the least common multiple for these two numbers, that I can multiply all these numbers what are in both circle and in the intersection. So I have 2 times this 2 times this 2 and times 3. So I can see that as a 2 on a power of 3 times 3. But also, I can figure it out what that number is. Who can tell me what this number is? Okay. Kevin, can you multiply for me, please? Kevin?
Yes.
What is 2 times 2?
Is 4.
4 times
2
2?
times 3 is 4 times 2 is 8.
And 8 times 3 is?
Wait.
24.
24. Thanks for help, Alex. Excellent. Look what we did. 2 times 2 is 4. And then 4 times 2 is 8. And 8 times 3 equals 24. There you go. So we know that the least common multiple is 24, and the greatest common factor is 4. So the question is, why do we have to know it? You see, this is a way that you can use if you need to simplify fractions. You can use this greatest common factor. If you need to add or subtract fractions, you can use their least common multiple. And then we can perform that by doing the sample. So now we know what our greatest common factor is and what least common multiple is. If we have, for example, I needed to simplify 8 twelfths. So if they say find a simple form or 8 twelfths, and then I know, oh, what do I need to divide numerator and denominator? So I can think, some of you will figure it out right away, but in a case you don't, you can say, oh, I can find their greatest common factor, and in this case is 4. So that means I can divide the numerator and denominator by 4, and I will have a simple reduced fraction or simple form of that fraction. Who knows what 8 divided by 4 is? What is what number times 4 equals 8?
It's 2.
2. And what number times 4 equals 12?
3.
So we can see that 8 twelfths is the same as a 2/3. And that is, we use the greatest common factor to simplify. So you can see that this means is greatest common factor that you use to simplify the fraction. Okay. Okay. Now, if I have to add or subtract the numbers, I can also see, like if I have, let's see, 6 twelfths, and I need subtract, like from there, 2 eighths. I can see that I can use this least common multiple. In the fractions, we call it least common denominator. But you know that that is actually least common multiple. Then we can change, because 12 pieces are not as big as 8. 8s are red. Remember, we were seeing how the difference in between these. is that if I'm thinking about eights are this size. And if I'm thinking about 12s, those are the 12 size. You can see with they're not the same pieces. So they are not the same size. So what that helps me, then I can use least common denominator or least common least common multiple or least common denominator to subtract these two fractions. So what that means is that I am least common multiple is 24. So I know that I have to change the 12 into 24 and 8 into 24. Okay, who is volunteer to tell me what could I multiply 12 by to get 24? Come on, guys.
2.
Okay, thank you, Alex. I appreciate you responding quickly. Times 2. And then what do I got? 6 12s are same as what? What is 6 times 2? Alex, stay with me.
1/2.
Ah, 1/2. Okay, but do I need a half? Or I need a 6 times 2? I need to change everything in 24 pieces. So, Anilada, what is 6 times 2?
6 times 2 is 12, and 12 times 2 is 24.
So that means 6 12s are same as 12 24s. And then what do I do with the second number, Anilada? I need to change into
You multiply it by 2.
8 times 2 is 16. What do I need to get? 8 times
24.
Yeah, so what did that multiple?
3.
3. Bravo. Thanks for it's okay. We'll all practice learning and we can you needed time to think. What is 2 times 3?
6.
And what is 3 times 8?
24.
That's right. So now when pieces are the same, I can subtract, and that is equal to 12 24ths. When you take away 6 24ths from it, what do you get?
You get 6 24ths.
6 24ths. And now you can also tell me, if you have a 6 24ths, how I can simplify that. Is it possible to simplify, which I am using greatest common factor? What is the greatest common factor for 6 and 24? What do you think?
2.
That's not the greatest. You know, I can divide by 2 and it will get 6 times 2. It will give me 3 12s. But then I have to keep going. So that's what we can just do. Very example, Anilada. So stay with me, okay? So I need to find what is the greatest
3.
common factor. No, even the 3. Let's see what I'm gonna. So help me with this. So I need a 6 and 24. So I'm gonna first do prime factorization. 6 is made of 2 times 3, correct? And then 24. How I decompose 24, Anilada? Stay with me, please. Say again.
8 and 3.
Okay, I'm going to do 3 times 8. So, and then this one is not a prime, so I can decompose 8 also. So how I decompose 8?
2 and 4.
2 and 4, another prime, but again, 4 is not a prime. How do I decompose 4?
2 and 2.
Bravo. So look, now I can see that I can draw my circles. In one, it's gonna represent 6. Another gonna represent 24. So which number they have both in common? Which prime they have both in common?
2.
2. And then is there another one?
3.
So 3, okay. So then here is the 3 also. And then for 6, I don't have, I use these and I use that. For 6, I don't have nothing left. But for 8, I have a 2 and 2. In the case I need a least common multiple. But I really need the greatest common factor to simplify fractions. So what is a 2 times 3? That's what it is in greatest common factor is what they have in both together. Greatest common factor.
Oh, okay.
So what is a 2 times 3? Is
6.
there you go. So you see, you found already greatest number that you can. It's okay. You could do 2, and then you will figure it out. You can do 3, but then finally you can see that actually you could just go and divide by 6, and you will get 1/4 as your final simple form of it. So I really would like you to understand that this is a good tool, good to find if you need the greatest common factor and least common multiple. So right now we can see, oh, that there is a greatest common factor is 2 times 3. That's a 6. But in a case that you need the least common denominator, least common denominator or least common multiple of 6 and 24, you can see that it's actually 2 times 3 times 2 times 2. Every number in both circles. In this one, we didn't have any left, but we have 2 and 3 and 2 and 2. So tell me, what is a 2 times 3? Anilada, what is it 2 times 3? We can see it as a fraction. We can see it as exponents. I have 2 and 2 and 2. That can make me 2 to the power of 3 times 3. But that is equal to, who's going to solve me this? 2 times 3 times 2 times 2. Come on, guys.
2 times 3 is 6.
Bravo. And
Times
then?
2 is 12. 12
And
times
then?
2 is 24.
Bravo. So least common multiple is going to be or least common denominator is needed to be 26. So in any case, I can create some number for you right now. I would like you to do, like, if I need to add 3, let's see, 3/24 and plus 4/6. You can see that the greatest common the denominator is 24, and then you can see that 24, the 3/24 are already there. So remember how I change in this problem both factors. I have a 12 divided times 2 changing 24, or an 8 change it into 24, 8 change it 24. But here, if I know, then my least common denominator has to be 24. I don't need it to change 24. It's already there. All I needed is to change the 6 to become a 24. Who is going to tell me what 6 times what makes 24? Come on, guys. Multiplication facts. 6 times what makes 24?
4.
4. And then I needed to do that also to do denominator. So finally, my problem will change if I needed to add the 3/24 plus add to it 4 times 4 is 4 times 4, guys.
Isn't
It's-
it 18? Wait, no. No, it's
It's
20.
okay. It's okay. 4 times 4 is 6.
No, 16.
16, and 6 times 4 is 24. Now I have both sides the same fractions. Now I have a 3/24 and add to it 16/24. So how many 24s is going to be, Alexander?
16.
Plus 3,
19.
19 24ths. And as you can see, 19 is one of the primes numbers. If you keep on going, adding this 13, and then you will have 17, and then you will have 19, it would be one prime numbers. And I can't go further and simplify this this fraction further. It's gonna stay as it 19 24ths. I hope we're gonna practice more about it, but I'm gonna help you how to use this tool to add, subtract, and simplify fractions. This was our first time. Are there any questions? No?
What's the meaning of life?
Okay, that's not the inappropriate question. I'm thinking about math, and this is a math class. Please be respectful. Alexander, thank you so much for your participation. Thanks, Alada. Thanks, Marcus, at the beginning. Thanks everyone who takes this lesson seriously. I love you, and I appreciate you being with me. Thank you.